Well, hello again, everybody. Mr. Taylor. We want to continue on looking at 8.2, and I believe we're looking at 8.2 A, B, and D. So, anyway, I think we're down to 8.2D, but we want to be able to look at these principal square roots and differentiate from the opposite of the principal square root. This particular time, we're going to work on actually looking at the square root of rational numbers. So remember we said when we're dealing with the opposite of the principal square root, we just change the sign of the answer that we get. And this is just telling us there's always two square root to every two principal or two roots to every square root. This is simply all it's telling us. Okay, so let's take a look at the first example that we're given. The opposite of the square root of 25 over 8. So when we look at it, we want to make sure that we take parts. So you want to look at this as the square root of 25, and we'll say the opposite, divided by the square root of 8. If you do that, then you're going to get something like the square root of 25 is 5, that is a perfect square, and the square root of 8 we know comes between 2 and 3. It is actually closer to 3 than 2. So we can say that that's roughly, well, let me go ahead and take my calculator and take a look. So if I do second x squared and put in 8, I'm going to get 2.83. So this is actually 2.83, and the only thing I'm going to do is divide. So if I divide 5 by 2.83, I'm going to get 1.767. Okay, so that's going to give me, I'm going to come up here and put that, actually 1.767, or really 1.78, and that's actually approximate. Now, if you notice what the actual book did, is the book apparently divided. So let's see how did the book get this. I want to make sure that we on target. So if I take 25 and divide by 8, I'm going to get 3.125, which is 3 1/8. And if I go back and take the square root of 3 1/8, I'll get 1.76. So it's actually the same thing. So we're saying two ways that we can do it. We can take this number, and inside we can divide, and then we'll get this number, and then we'll take the square root literally of 3 1/8, and that'll give us approximately 1.77, and since we have the opposite, that will be a negative. Now, when we're dealing with the principal root, same concept. Again, I think this is a good, that's more than one way. So let's take a look at it. If we're looking at the square root of 25, we're going to get the square root of 5 over the square root of 8. And then we just work them out, the square root of 25 over the square root of 8, and that's going to give us 5 over 2.83. We divide again, and we get approximately 1.77. Okay? If we use a calculator, we'll get approximately 1.77, the exact same thing. So just remember, when you're looking at these principal roots, what we're doing, and the opposite of the principal root, once you find the square root, you just put a negative side, and then the principal root comes always positive. I believe, let's take a look at what the rest is saying, because I believe Yeah, the other part deals with the number line. Now, I'm going to leave this here for you to read because it's just dealing with the number line, definitions again, rational and irrational numbers, and how we find these numbers on the number line. You're just simply looking at where the numbers literally fall in regards. Let's just say if I'm looking for the square root of 6, well, I know that the square root of 6 come between the square root of 9 and the square root of 4. So I know that the square root of 4 is 2 and the square root of 9 is 3. So I go to my number line and I see, well, let's see, what are we doing these 5, 10. I'm just going to use the one tick mark. So this would give me 2 here, and this will give me 3 here. So my square root of 6 comes somewhere between there, those two numbers, which means that you definitely know we're going to get some floating number, some irrational number that goes along. So again, take a look at these, take a look at the definitions, and that's about it. Well, realistically, I better cover these because we've found out with these tests, they literally do more so of evaluating us on do we understand the why and the how. So here we're talking about characteristics of an open number line. Please re-familiarize yourself with the characteristics of an open number line. This verbiage is quite important, very, very important to you. Then also take a look at rational numbers appropriation. Now, when I put this inside of Google Classroom, I'm going to put this document, and you will get a chance to take this document and keep it for your own notes. I mean, we won't be giving notes out in class, so this semester you will have to come up, this 9 week, you're going to have to be able to print these notes yourself or take them, put them on your phone or your iPad or whatever, and then go over them. So example, perfect squares, we need to know perfect squares from 1, and I believe it says to 15. And when we do a perfect square, we just multiply the numbers by itself. So 1 times 1, and then 2 times 2, 3 times 3, and so on. So those are perfect squares. We can also make sure that we locate, again, like I said, on the number line, what is the opposite of a square root and the square root. And we need to, at times, determine the distance between that, but this distance can always be positive. So again, there you have it. We're going through this, actually refamiliarizing ourselves with this particular number line and rational and irrational numbers. All right. This is Mr. Taylor, and I'll talk to you soon.